Hello.
Uh,
Hi.
hi everybody. Natalie, thanks for your introduction. And for those of you who might have chance to see my pre-recorded video in the beginning of the conference, this time I'm real and alive, sitting here, presenting from New York. And let me share my screen first. Okay. So hope you can see the slides now, all right?
Yes,
so
good.
welcome to AnyLogic 9 workshop. AnyLogic 9 progress. As I said before, in the intro, it is really progressing well. I'm happy, and the development team is really gaining speed. So today, instead of telling you this is what you guys have seen last year at the AnyLogic Conference 23, and this is what has been completed since then, and this is still to do, we of course decided to give you another big dose of AnyLogic 9 user experience in the form of a live project performed in front of you, and three of us will be playing different roles. But before we go ahead, just some notes. We have attendees who signed up for this workshop, and those have cheat sheets, and they can follow these cheat sheets and develop the same model at your own speed. Now, the other option, and for others, this is the only option, you just sit back, relax, and watch us doing the work. Now, because it's really intensive modeling, there is no option C. You will not be able to kind of follow us on your laptops. So please choose whatever you want to do, or you can maybe choose to do some steps on your own, following the cheat sheets, and then complete that afterwards, because your accounts will be valid for Yulia. Is that 1 month, right? From now.
1 month, right?
1 month, yeah. So yeah, there's no rush. Okay, so the project will be about optimizing motor oil supply chain, and who's who. So we have a consulting company operating out of Europe, represented today by two simulation modeling experts, Yulia Tropina and Nikolai Churkov, working from two different locations in Europe. And I am a supply chain manager working for a retail company in the United States, and working and operating out of and presenting from New York. Okay, so I go first and I do the problem statements, and then I will just pass the presenting to the consulting guys. So what do we have here? We have as many as 500 oil change stations. They consume motor oil at some, let's assume, constant but different rates. And they, when oil is close to being finished, they order 1 barrel of oil at a time. Now, I work for this company, for the retailer, and I ship barrels of oil to those oil change stations. And we adopted min-max inventory policy, which is, of course, when the inventory reaches S minimum, we order to replenish up to S maximum. Now there's factory, and factory is my supplier, and I order, kind of batches, or maybe like 10, 12, 50 oil barrels from the factory when I think I need to order more. And this is the goal of the project. So guys, you are to find optimal inventory policy for me, ensuring that my inventory over time is minimum, and at the same time I do provide certain quality of service to my clients, who are the oil change stations. Now the next slide I will go very go through very briefly, but before we go to numbers, which are a necessary part of any problems statement. Of course, just some kind of disclaimer for the sake of saving time. We will not be adjusting changing units. We will use whatever default volume and time units are in the model. So we have some numbers for the oil change station, like consumption and oil levels, and then we have inventory policy for the retailer, my company, and then we have some numbers, some parameters for the factory. And what's important, that quality of service criteria I must meet is at any point in time the number of stations out of oil should be below 1%. With that said, I stop sharing my screen, and guys, you have exactly maybe already less than an hour to give me an answer. Please go ahead.
Okay, thank you, Andrei. Then let me share my screen. I'll start. Can you see it?
Yeah. Yeah, see already.
Cool. So I'm already logged into cloud. So please, those of you who have credentials, log in also. And I'll create a new model here called motor oil supply chain. Here it is. So currently the model is being created. And now let's talk about how to map the problem that Andrew described to the modeling languages. So typically supply chain models are agent-based, where every agent has its own behavior. And we'll start here with the two agent types, one standing for oil change station and another standing for the retailer. So we'll have a population of oil change stations of size 500, if I remember that correctly, and just a single retailer. So let's go ahead. So the model is created. It is stored in AnyLogic Cloud, and we see the main or root agent here. Okay, so I'm creating a new agent type, and we'll call it oil change station. Okay, so I'm going to add a picture here. Let it be a house. Enlarge it a bit, make sure it will serve as an agent icon. And we'll add it to our top level agent. Here it is. And I'll need one more agent type, which is retailer. We'll use retail store as a picture here. Again, enlarge, market as icon, and add it to the main as well. Okay, so as I said, we have a population of oil change stations. So let's rename them and make it have a size 500. Okay, so the very basic structure, very high level architecture. And now let's get into oil change station consumption behavior. So since we deal with oil, probably we can use a fluid library here, and we'll need a tank there to store this oil. So Andrew, may we assume that consumption rate is constant?
Yeah, for this problem, we can well assume it's constant. However, it differs from one station to another, so it's not same for every station.
Okay. It's not the same, and we probably will have also different initial amount of oil at every station, right?
Correct. That also may differ, of course.
Okay, so then I'm switching to fluid library and selecting a tank here. So it has a capacity of 20. Since we are dealing with a constant rate, we can use valve as a consumption. And as Andrei said, the rate is constant, but different for
Yeah,
each
it's
station.
uniform from 0.2 to 0.8.
Mm-hmm. So by the way, I even don't need to press Control Space to call code completion. When I just pause, it's called automatically. Wait when open. Okay, and I forgot to set initial amount here.
Yeah, it's also different from station to station. Let's assume it's uniform from 5 to 20 volume units.
5 to 20. Okay, cool. And of course, any flow chart should end with a dispose block. Okay, and I'll also add an animation or presentation to oil change station to make it more dynamic. I'll use oval from the presentation palette. Let it be some small radius, no line color. Well, in correspondence to fluid library, let the default fill color to be royal blue, and let it change dynamically depending on the amount of oil in the tank. So, Andre, what will be the reordering point?
At the station, it's going to be, let it be 5.
5. Okay, then if amount is greater than 5, everything is okay, and let the animation be colored in royal blue. So if the amount is small, but still positive, then let's use, for example, Peru. And if we are out of oil, then let it be red. Okay, so back to our main, and let's show that presentation we've just drawn. And I don't want all the presentation to appear here at runtime. That's why I'm adding a group. Let's move like here, for example. And I'll add this presentation to this group that I've just created. Here it is. And my last thing about their location is to change the layout type. I'm doing that in the top level agent because our oil change station, they live in our main agent. So I'm saying that the layout type will be random and they will live in a square with size equal to 250. Okay, so I think it's a point to run the model for the first time. So now the model is being compiled and is uploaded to the cloud. Okay, I have some error. So we have error view here that navigate us to the place where we have an error. So fill color code. Okay, what's wrong here?
Maybe you need to change the type of field.
No, it's a conditional operator when they check the tank amount.
Oh yeah, it's
I
just
I just misprint here.
Yeah,
that's it.
Mm-hmm.
Okay, cool. Let's try again. And see what will happen. Okay, we see that at the starting point, all ovals are blue, then they become Peru because they spending oil, and we have more and more red ovals. And of course, at the end, all of them are red because no more oil, and they do not order oil right now. Okay, then let us concentrate on the ordering behavior now. So each oil station will send an order to the retailer asking to send a barrel in response. To model this communication, we will have a new agent type, because everything is an agent in AnyLogic, which will be parameterized with the address of this oil change station, because retailer needs to know where to send this barrel. And so that's the idea. Let's go to the editor again. So I'm creating a new agent type, call it station order. Okay. And as I said, it should be parameterized. So I'm switching to basic palette and create a parameter, call it station. And it should have a type, which is oil change station, the agent type that we have created. Okay, so now we'll create an entry point in a retailer. So how the retailer can receive these orders. I will use process modeling palette for this, and use entry block. Call it station orders. And make sure that it works with this message or agent type station order. Okay, this is just an entry point, and now let's get into oil change station again to model the ordering behavior. Okay, so first, an oil change station needs to know where to order. To do that, it can be done in multiple ways. Here we'll create a parameter. We call it retailer, specify the retailer type. So this will be our recipient of the message. So now let's go to tank, and so as we already discussed, the reordering point is 5. Is that correct? 5, right?
Yes, that is correct.
It's 5. Okay, and now the way to communicate with the retailer to send an order is to call the retailer. Then we call the entry point that we have just created, which is station orders. It has a function called take, and we need to create a new order here. New station order. I'll enlarge the properties. And this station order should be parameterized with this particular oil change station. So this here stands for oil change station we are in. Okay, so the order will go to the retailer, and then the retailer will send a barrel in response. And what should happen when the oil change station receives it? Let's model this behavior. So just as we have it for retailer, we'll also have an entry point here, which is enter from process modeling library, and call it delivery. Okay, now need to specify agent type here, because a barrel doesn't need any parameters, and we can go further with just regular agent type. And now we need to convert this barrel into a fluid. To do this, I switch back to fluid library and add agent to fluid block, which I'll call refill. So how much oil is there in a barrel, Andrei?
All barrels are the same. Each barrel has a capacity of 15 volume units of oil.
15. Okay, and I guess just some pretty big rate. We are good with this for now. Okay, so we have specified the parameter for oil change station type, and now let's set this parameter for our real oil change station that we have created. So I'm getting back to main, and I'm specifying here the parameter to our real retailer that exists here in main. And now let's model the behavior inside the retailer where we just have an entry point for now. So I guess that when order enters, it should first probably stored in some backlog with unlimited capacity. And then depending on whether we have enough stock or not, we should ship it. So to deal with stock, we'll use a variable from our basic palette, call it stock. So it should be an integer because barrels are discrete items, obviously. And let it have the initial value of, let's say, 500. Okay, now to shipment. We will model the shipment with the simplest way, just using hold block, call it ship. And how to deal with this. So if, as I said, we can ship only if we have enough stock. So this hold should be blocked if we don't have enough stock. Let's use conditional mode then. And specify the condition here, stock is less than or equal to 0. If we have enough stock, then we can send an order. I'm specifying an enter action then, and similar to the way we access the retailer to send order there, we'll access the station now. So here we deal with station orders. And it can be accessed as agent. So each agent, each order knows the station it goes from. Each station has an entry point that's called delivery and called take function again. And to send a barrel, just create a new general agent. So no parameters to specify here. And of course, stock should be decreased then. Okay, and just last block in flowchart, done. Okay, that's it. Very simple, yet realistic to a certain point behavior. And let's add just one chart to our model. I'm switching to analysis palette, and I'll add a time plot here, which will depict the retailer stock. Okay, retailer dot stock. So let's change color. I also want it to have fixed scale from 0 to 500. For better visualization, I will fill area underline. No need for second data item. Okay, that's it. Let's try to run the model. Again, every time I press play, the model first is being compiled. And in case of errors, you know that error view appear. Okay, all is good now. And let's see how it will behave. Okay, so I see a lot of blue ovals and some pearl sparks. Because they order from the retailer, and we can see that the retailer stock decreases, drops down. Let's go further. Okay, yes, of course. Once we are run out of stock in the retailer, then more and more red ovals, and at some point, all of them are red. Okay, well, that's it. And according to my role today, at this point, I need to jump to another project, and that's why I'll share the access with with another developer who is Nikolai, and ask him to continue. So I'm selecting developer role and send the invitation. And since I already have something to show, I can also share it with the client. So I'll also invite Andre, but not as a developer, as a user.
Thank
Okay.
you. Appreciate that, Yue, and sorry to see you go.
Okay, so
Okay.
I'm jumping. Nikolai, can you continue?
Yeah.
I'm stop sharing them.
And I start sharing my screen. According to my role, I jump to another project. To the project Yulia has finished up to this phase, and here is the screen where Yulia's model is shared with me and Andre. Andre is still unconfirmed, but hopefully he'll confirm it. So this model has several versions. Or may have several versions. The first version created by Yulia, so I create a new branch here and name it like this and open it in AnyLogic. This slide here. So current step, we have a retailer who runs out of stock, so we need to replenish it. And we'll be creating a factory in our model, and we need to set up some communication between them. We could use the same approach as Yulia did for communication between oil change stations and the retailer, like using these parameters. But since we have flowchart inside our retailer, and we will have a flowchart inside our factory, we can simply connect them using ports and connectors. And there will be an agent traveling between them for order and for the shipment, and we will utilize just one agent type retail order, and we'll have a couple of ports in the retailer and in the factory as well. One for placing orders and another one for shipment delivery. So let's switch back to AnyLogic. So this is the model. Okay, we see here oil change stations, retailer. Now let's add factory. So I create an agent type for our factory. And let's add this icon here. There will be an agent icon, and as I said, we will create a couple of ports here. One for orders. We hide its name. We don't need to show its name, and another one for shipments. And these ports are already part of agent icon. And now let's add a couple of ports in our retailer. So I go here and create one port for orders and another port for deliveries. So now I'll add a factory into the model. If I drag it and drop it onto the canvas, you can see these two ports are connected automatically, and I connect bottom ports manually. So I've just set up the interaction in between of these two agents, and they will utilize an agent type for the orders and shipments, which will be our retail order. Now let's create it. This one will represent an entity which will be traveling via those ports. This retail order will have a parameter amount, which will be an integer number of barrels ordered by our retailer or shipped back from factory to retailer. And we do not need to specify here like shipping address of our retailer, since we have only one retailer in our model. Okay, so now let's go into these blocks and define how do they interact, how do they order, ship, produce, etc. So we go into retailer, and this we currently have just stock here with which falls down to 0, and we will be ordering more barrels of oil, so we will be expecting some number of oils to be delivered. I create here another variable, which will be a number of barrels which are on the way from the factory to our retailer. And now I want to define here our inventory replenishment policy. Andrei, which type of policy do you want to implement?
Yeah, so as I said, it's a simple one, but it should work for us. It's a min-max inventory policy, where we have two parameters. I mean, the reordering level and order up to. So it's like S-min, S-max, and yeah, and the actual numbers, it's something you have to find out for me.
Okay, so I create here two parameters. The first one will be S-min and S-max, and it will be of integer type, and it will have value of 500 by default. And another one will be, I just control dragging it, will be S-min. We'll have a value of say 100 by default, and this will be parameters for our min-max inventory policy. And we'll be definitely placing orders and send it to our factory. So we need here an enter block from the process modeling library palette. And
I'm sorry, I have a question. Do we want a stock to always to be 500 at starting point? I mean,
no.
Well,
Okay,
yeah. What I told you in the beginning, that you can assume that initial stock is equals to S max, but it's yeah.
okay.
Sure, thank you. Yeah, and so now I'm creating here an enter block placeholder. And connecting it to our top port. So now let's define our inventory policy. So here in this ship block, we send out our 1 barrel of oil to the oil change station and decrease our stock. And it's the right place where we should check if our stock gets below some level. So if I write here this condition, if our stock, including the number of barrels which are on the way, which we are expecting from the factory, if this number gets below some reordering point, which is S min, we need to place an order. How many barrels should we order? We should order some number for us to get back to S max level. So we find here a variable. And then we place this order. So we call take function of our place order enter block and create a new retailer order with this amount. And we need to increase the expecting variable by this number. And okay, what I've currently done, so this piece of code is actually the core of our model, which defines the inventory policy inside our retailer, and it will define the model behavior, and we'll work next to optimize parameters of this inventory replenishment policy. So now at some time we place an order, it goes to the factory, then factory produces barrels of oil, ships, and we receive them back here from the bottom port. We need sync block here, which will be delivery. And that will have agent type retailer order and then action. So we should increase the stock by the amount we received. We refer to the shipment by the agent word, and we have here amount parameter. So we increase the stock and we decrease the expecting variable by the same amount. And we need to ask our ship block to recalculate its conditions, since it doesn't constantly monitor the stock level, and it has a condition based on this stock level. Okay, so now we are done with our retailer, and let's go to the factory and to define the production logic. So Andrei, regarding the production, we have two parameters here, right?
Yeah, you can, well, first of all, the factory can only deal and can only produce one order at a time. It cannot produce in parallel. This is one thing. And with regards to how long does it take to fulfill, to produce and fulfill an order, there is some setup time of 2, whatever, time units. And then for each barrel in the order, the production time is 0.04.
Okay, got it. So we have setup time, which will have default value of 2. And the item production time. So each barrel production will take this time.
Correct.
Okay, and since we can produce only one shipment, or can handle only one order at a time, we need a queue here for the backlog of our orders. Let's assume maximum capacity for this queue and the agent type of retailer order. Okay, then the production. So we will simply use delay here to model our production. and it'll have a capacity of 1 by default. So it's good for us since we can handle only one order at a time. And the delay time here will be a sum of our setup time and the ordered amount, which we can get here as a parameter of our agent, multiplied by item production time. Okay. And once it's produced, it will be sent to the bottom port and then received by our retailer. Now let's run this model to check that everything works and to observe what will happen with our inventory, with our stock level on the retailer side. So previously we saw the chart which was falling down to 0 and stayed there. Now if I speed the model up, we can see that retailer somehow replenishes its stock level, not to 500, but to something on this chart. And we still see that some of these oil change stations are getting red from time to time. Okay, now let's count them. So we can add statistics to the agent population, oil change stations. It's here in the statistics section. And let's add one. We'll call it N out of oil, which will be of count type. And the condition here will be, so item here is the reference to each of oil change stations in the population. And we remember they have tanks inside, and we call amount here, and we get an amount. And if the oil change station tank gets out of oil, we count it here, and we will use it in these statistics. And now let's display it. So I create one more chart here just by duplicating this one. It will be another chart for our stations out of oil. The value will be that statistics. So we call oil change stations dot n out of oil function, and it will evaluate the statistics. It will count the agents each time it's called, and the color will be red here. Okay, so now we kind of have two charts here on the main level, and we remember we have a task definition where we want to operate with min-max parameters to find the best solution based on something related to our retailer stock and the stations which are out of oil. So we have these inventory policy parameters here on the retailer level, and let's create these parameters. Let's expose them onto the main level. So I copy them and paste them here, and I propagate their values to the retailer agent. And as all the animations in AnyLogic can be interactive, let's add controls here. So I can add slider for Smax parameter. So it will be linked to Smax, and it will have a range of 0 to 500, and one more slider for our Smin parameter. So now let's check the model. So I press the run button, model is currently being saved, compiled. Okay. I'll speed it up. You see this chart, and now let's play with these sliders. So we can see the model reacts on my actions. So at this point, I'd like to share the model with the customer. So I close it here, and Andrei, please try this
All right,
model.
guys, let's see. It's been already 40 minutes. So, let me share my browser. So that is the model actually you delivered, right? And
Try to
You
refresh the
you
page.
need to refresh the page here.
okay. Okay, so what do I do now?
So please go to my version, which is called Mix version, and select experiment.
This one?
Yeah.
Okay. And then I assume I should run it, right? This way.
Right.
Yeah,
Right.
okay. All right, let's see. Okay, so it's something happens in the model, and I used to speed it up. So what do I see? Okay, so that's fine. This is my inventory, and this is what? This is the number of stations out of oil. So I see that out of oil cases happen, and I don't like it, so I can play with the parameters, right? So I let's say S min is bigger, and does it anyhow? Oh no, that's not what I want. No, that's I don't want it. So let's then try something like very small S min. No, no good either. Okay, what if I then make them both like here and okay, okay guys, so basically, I mean the model, I like the model, it kind of looks good. It's sort of represents the behavior of my business. However, unfortunately, this is not the answer I wanted, because what I didn't want the model. I did want my the parameters of my supply chain, basically. So, and it's already 2:46 p.m. here in New York, and okay, you have 14 minutes to give me the answer. So please.
Okay. So I start sharing my screen again. So at this point, we need to define some formal metrics for our model for in order to perform some optimization. So as the model gets uploaded on AnyLogic Cloud, we can perform experiments there. We have parameters. Now let's define some outputs. So let's create statistics here. I switch to the analysis palette and add the statistics for, I guess, for our retailer stock. Which will be a statistics of continuous type, and it will get the value of retailer stock variable. It will be updated automatically. And one more statistics here. So we need to count to react on the number of oil change stations which are running out of oil. So we need statistics for that. And its value will be oil change stations and out of oil. So this is just a number, and the whole element statistics is the element who observes these numbers during the whole model run. And at the model simulation end, we want to get these numbers and send them to AnyLogic Cloud. So we create an output here, which will be Andrei, what do we want to be our objective?
Yeah, right. So okay. My task is to keep inventory at the possible minimum, right? So to minimize the inventory, and by inventory I mean let's say average inventory throughout the whole period where we're modeling.
Okay, so we can just ask our statistics to return the mean value on the simulation end here. And regarding the requirement, we want our oil change stations running out of oil. We want this number to be the maximum number during the whole simulation run to be less than some.
Yes, Nikolai, at any given point in time, the number of oil change stations out of oil with no oil in there should be not bigger, not higher than 1%.
Okay. So will be the maximum value found so far during the whole simulation run divided by the number of our oil change stations. Okay, now I open the experiments panel in AnyLogic Cloud. I press here, and the model is being compiled and uploaded to AnyLogic Cloud.
Just so you know, guys, you only have 10 minutes.
Okay, and I'll create an optimization experiment here. Switch to dashboard editor. So we see here inputs which are Smin and Smax, and they will be varied in discrete range. We'll have objective here. Okay, let's display stop time input, and we'll react on the maximum percent out of oil. The outputs dashboard for our experiment, let's add a couple for our parameters. So optimizer will find Smin and Smax values, so we want to show them here. Actually, they will be outputs of our experiment. Okay, now let's define ranges here. For Smax, it will be from 100 to 500 with steps, say, 10. For Smin, from 0 to 400. Same step. Okay. So we'll be minimizing mean retailer stock, number of iterations, let's set it to 200, stop time, okay. Maximum percentage of our oil change stations running out of oil less than or equal to 1%. Okay, save the experiment. Now I started. And Andrei, so you can, right now, you can actually switch to the same page I'm looking to. So I can stop sharing the screen, and I ask you to refresh your page.
Okay, let's see. Right now I see nothing, but you said I need to refresh, right?
Right.
So I see some optimization here. It is in progress. So tell me, guys, what actually is happening right now?
So there is an optimization engine in AnyLogic Cloud which utilizes genetic algorithm. It suggests a set of possible solutions, namely the pairs of Smin and Smax values, and passes them to the model execution environment. So simulations are executed, and the objective and requirement values are obtained from those simulations. After that, optimizer takes the next step, suggests a new set of inputs, and so on. And after that, so during this process, optimizer tries to find the best solutions, keep them, produces more solutions, and after that,
Okay,
after that we
let me
can see.
see. Is it done now?
Yeah, it's done. At the
So,
end of optimization, we can see the
so
SMIN and SMAX values.
what are these charts actually?
So these are outputs of the simulation run, which corresponds to the best values of of SMIN SMAX parameters found by the optimizer.
And oh, okay. So so are these the best values? This
Yeah,
is what do you guys recommend for
Correct.
me to follow, to implement, right? And okay, and that is what? That is the mean stock. So does that actually mean that I can keep only as few as 2.3 actually? Okay, less than 3 barrels of oil at any time. Is this what you're saying?
it's
No,
the
not at
mean.
any time. It's a mean value. So
Okay. And so in this run, so nobody's out of oil. Is this correct?
it
Correct,
seems
but we
so.
have simulation stop time here, and at any time you can actually run this model in
Can I actually test
animation.
this somehow within your model?
Yeah,
Yeah.
just
So
press the play button.
this one, right?
Right, and it will start
Okay.
experiment with the best solution.
So now I'm kind of running, animated model with the parameters set to kind of optimum you found within this experiment.
Yeah.
Correct.
All right. Okay. Let's. Can I? Yeah, I can speed it up a little bit. Okay. Not too bad. I mean, it really looks kind of making sense. And then so nobody out of oil. Is this kind of real? Can I run it like, oh, I see.
You could switch it to the full screen and open the developer panel, so we can see the time.
Here, right?
So
It's
quite a
okay.
long time model so far, and so we had maximum of one oil change stations out of oil at a time.
Cool.
No 1%, just one.
Yeah. Guys, well, it's 2:57. So you met the deadline. Looks good. I'll stop sharing here. And so thank you, Yulia. Thank you, Nikolai. I think you actually did great. I will be back to you. I mean, what actually what happens? I mean, if I have some new input for you guys, I mean, some new data, I mean, or new parameters, or my business changes, right? And can I sort of reuse? I mean, or it's just one-time project and everything is thrown away.
Oh, the model
Yes, you
sits
can.
there, so we can edit it at any time, or we can invite more developers. And if you buy AnyLogic license, we could invite you as a developer for this model. You don't
All
need to
right.
install
So
anything. You just
so
open it in a browser and continue
okay.
editing there. So
Yeah, absolutely. So yeah.
Yeah, so if I kind of opt to growing in-house expertise for simulation, I mean my guys can still access it in the cloud and do some changes. Is that what we're
Yes,
saying?
absolutely.
Cool.
We'll just share this model with them as a developer.
Cool. All right. So thank you, everybody. So thanks for watching. I hope it was not too boring, although we did a lot. And actually, that was there was a lot of kind of practical stuff in this model, because when you create agent-based models, you need to, design how, components of your model communicate, and we did that. We combined some discrete and continuous modeling in the model, and also what we actually demoed. I mean, we are currently in geographically very distributed, working from 3 different locations, and we were using AnyLogic Cloud as our platform, not only to deliver a model for the customer, but also to exchange to pass it back and forth between the modelers, the developers team. So thank you, and also our thanks to the development team, who is really doing great. So they have even tougher deadlines, and we're putting a lot of pressure on them. Please believe us. So yeah, thanks everybody, and once again, I'm really happy, to see you guys, with us at this, another AnyLogic conference, and we will continue our journey. Thank you.
Thank
Thank
you.
you. Bye.
Bye.